Okay, let's continue the discussion on linear shift invariant systems. Um, so we've seen what shift invariant systems are. We also looked at what is known as the impulse response. So basically, the impulse response is the response of a system if we give the input as a canonical delta. Not necessarily canonical delta, but a delta function. But in our case, since we are dealing with discrete systems, we look at canonical delta. So we also seen how we've defined canonical delta. So what we're claiming here is, suppose we have uh, an output of a function f of mn when it's passed as through a system t, then if you know the impulse response h of mn, then basically to find the response of that particular system for a function f, basically we have to convolve f and its impulse response. You basically, if you do the convolution between f and h, you end up getting the corresponding g. This is a claim. Let's see how we can prove this. So f of mn, can be written in terms of the delta for canonical delta. So what I mean here is, let's say, okay, yeah, I think even with this is understandable. Let's say we have something like this here. Okay, I don't have to use an arrow. It's a canonical delta. This is a canonical delta. I'm talking about the 1D case. You can extend it to a plane. So this is a delta of 0, right? Then what will happen if I shift this by minus k? So this will get shifted to somewhere here, right? This is delta of minus k. And suppose I have to shift it to delta of minus k plus 1. Minus of k plus 1. This is how it is going to look. So it is getting shifted. So this is just the value of the function at yeah, whenever we are multiplying a function, suppose we have a function like this, some value, something like this. So whenever I'm multiplying this function with delta of 0, I end up getting this sample. And if I'm okay, let's say I shift it here. Okay, this. So I multiply this with this function, I end up getting this sample. I multiply this with this function, I get this sample. So if I multiply, I shift the deltas along the entire domain and multiply the its corresponding fkl, or if I know the corresponding fk value, then adding all of them together, if I put all of these together, finally I can end up getting the signal, right? So that is what is written here. So if you shift delta, delta mn by values k and l, and if you know this corresponding function values at k and l, if you multiply the function with those values and add it for the entire set of k's and l, you will get f of mn. That is the idea here. Where, okay, this is where delta of m minus k m minus n is 1 when m is equal to k, n is equal to l, and 0 elsewhere. This is basically the shifted canonical delta. So we're trying to apply the transformation on f of mn. Note that this is linear shift invariant transformation. Okay, only then we can apply this. So we've written f of mn in using the canonical delta. F of mn can be written as sigma over the entire L, sigma over entire k, f of kl into delta of m minus k into n minus l. Yeah. And the transformation is being applied on the entire f of mn. But since f is it's linear and it is okay. The first property which we're going to apply is it is linear. So since it's linear, these are just basically some coefficients, some scalars which we are multiplying. F of kl can be either some alphas or betas, right? Some scalars. Use some other pen. These are basically scalars, right? Yeah. And this is one part. So since they're scalars, you can take them outside and put the corresponding transformation inside. Also, T is shift invariant. So basically, if you shift the input, its corresponding output is the impulse response h, which will be also shifted by a similar value. So T of delta f m minus k into n minus L will be h of m minus k n minus L. So here we've used two properties. One is linearity plus shift invariance. So this is basically what you get, and uh, so yeah, what is this? This is basically the convolution equation for 2D convolution in the discrete setting. Uh, so you can write this as f convolution h, and you also know that if you interchange the functions, convolutions does not change. Like f convolution h is same as h convolution f. So that is also this can be proved by a simple change of variable formulation. So this proves for a linear shift invariant system, if you know the impulse response, then we have to get a response of a particular function. We basically have to just take the convolution of that function with the impulse response. Okay, let's conclude this lecture here.